Hello and good afternoon, my dear kids. Welcome back once again to this short tutorial video for class 8 students. And since on the previous video we have dealt with the types of quadrilaterals, and in this video we will be dealing with the sums on types of quadrilaterals. Okay, so I hope you kids have gone through the previous video, because see, as I've already told you in the end of previous video as well, once if you couldn't recall the properties of certain type of quadrilaterals, then it will be very hard for you to understand, okay, as well as to solve the sums as well. Okay, so okay, so here I picked this from exercise 19b because see, exercise 19a it just had a few basics regarding the types of quadrilaterals. Okay, so therefore I have simply picked up the from exercise 19b, that is directly sums. Exercise 19a, as I have already said, had a few basics that we have already discussed on the previous video. So those who go through the previous video, they can easily solve question number 9, exercise 19a. Okay, so okay, exercise 19b, question number a, question number 1, what we have is in a parallelogram. Now recall the terms in a parallelogram. So as soon as we hear the term parallelogram, what does it mean? And that means the opposite sides will be equal, the opposite angles will be equal, isn't it? The opposite sides and the opposite angles will be equal. And here we didn't have the figure as well, so I have plotted my own figure. See, in a parallelogram, so if you plot out the figure on your own, it will be easier for you as well to understand. Okay, in a parallelogram, PQRS, angle S is equals to 75 degree. Determine the measures of angle P and angle Q. See, in a parallelogram, PQRS, angle S is equals to, we are given with one of the angles as 75 degree, and we need to determine the measures of angle P and Q. So what I have done here is I have drawn a quadrilateral and I have marked the points as P, Q, R and S. Okay, P, Q, R, S, R and S. As I have already told you how to mark the figure as well, isn't it? Anti-clockwise, P, Q, R, S. Okay, and what do I have here is angle S equals 75 degree. So I have marked angle S as 75 degree. Now since it's a parallelogram, what do I know? Opposite sides are parallel, opposite sides are equal. So that is what I have marked here with the symbols and all. Now I do know the opposite angles are also equal, isn't it? And we need to find angle P and angle Q. So see, so it's simple. Angle Q will be equal to 75 degree, isn't it? So that's what I have written here at the first. See, angle S is equals to angle Q, opposite angles. So opposite angles, actually you need to write opposite angles of a parallelogram. Okay, and this is also how you can write parallelogram, double L GM. See, okay, because double L means parallel, isn't it? Parallelogram. So this is also how you can denote parallelogram. Okay, double L GM. So opposite angles of a parallelogram. Okay, so that is how we get to know the value of angle Q as 75 degree. Angle Q equals 75 degree. Okay, now in a parallelogram, what we learned in the parallelogram? Alternate interior angles. Alternate interior, the sum of alternate interior angles are supplementary. That's what we have known, isn't it? So see, that is why, see, angle S is equals to angle P, because we need to find angle P afterwards, isn't it? So angle S and angle P, the sum will be equal to 180 degree. And the reasoning, as I have already said, the reasoning is very important. So angle S plus angle P equals 180 degree. The reason is, what is the reason? Angles on the same side of transversal. Or you can simply write interior angles as well. Okay, you can simply write interior angles as well. So angle S is equals to angle P 180 degree. Angle S we have as 75 degrees, so 75, and there we got the value of angle P as 180 degree. Okay, angle P as 180 degree. 75 plus P 180 degree. 75 goes to other side, subtracts. 180 minus 75 is 105 degree. As I've already told you, you can skip few steps as well in order to save your time. Okay, so it is 105 degree. So okay, for the next question we have here is, again the figure wasn't given in the question, so I have to draw my own figure. So I drew a figure as well. See, the measures of two adjacent angles of a parallelogram. Now see, adjacent angles, side by side angles. Adjacent means, isn't it? The measure of two adjacent angles of a parallelogram are in the ratio 2:7. Find all the angles. So we need to find all the other angles as well. Now, before going, so what did I said about ratio in a word problem? Whenever you see ratio in a word problem, you have to, first of all, you need to assume the ratio as whole numbers, isn't it? So that is what I have done here. First of all, see, let the angles be 2x and 7x. Now we were not given with the diagram, so I have drawn a diagram, a parallelogram. So because see, the question states the measure of two adjacent angles of a parallelogram. See, parallelogram. So that's why I've drawn parallelogram. And since you are familiar with PQRS, we are doing simply just PQRS and all, isn't it? You can change the name as well. But since you are familiar with PQRS, so I have given the name PQRS. Okay. Now two adjacent angles are given in the ratio 2:7, and I said we need to assume from ratio to a whole number, so 2x and 7x. Now simply I have assumed those two angles adjacent angles as P and S. See, 2x and 7x, these two are adjacent angles, isn't it? So now, what do we need to find? All the angles. Okay, we need to find all the other angles. Now, 2x plus 7x equals to 180 degree. That's what we know, angles on the same side of transversal, isn't it? We can call it angles on the same side of transversal, or alternate or interior angles. Okay, or we can call it as interior angles as well, or we can call it as co-interior angles as well. Okay, this is from the concept of parallel lines and transversal from class 7, remember that. And if you couldn't recall it, then you can go to the class 7 video where it is given for the topic. I have given a video, parallel lines and transversal. Okay, so 2x plus 7x equals to 180 degree. So you know the drill, isn't it? 2 plus 7, like term added, 9x equals to 180 degree. Now 9 goes to the other side, divides 180, so x equals to 20. Remember, x is not our angle. Our angles are 2x and 7x. Okay, so therefore the angles are, I have substituted 2x, 2 into 20, that is 40 degree, and 7 into 20, that is 140 degree. Now, okay, I got these two angles as S as 140 degree, this angle as 40 degree, 2x as 40 degree. Now what do I know in parallelogram? The opposite angles will also be equal, since we need to find all the angles, isn't it? We got, till now we got two angles, but now it's very easy for us, isn't it? Because we know the opposite angles of a parallelogram are equal as well. So we can simply write, and see, angle P is equals to now, and since angle P is equals to angle R, this angle will be equal, P and R, isn't it? Also, angle Q will be equal to angle S. Angle Q will be equal to angle S. What is the reason? See, reasoning. The most important thing on every sum, okay, while doing in geometric section, the reasoning is, as I have been repeatedly telling you, reasoning is very important. You don't need to miss the reasoning, okay? If you miss the reasoning, your marks will be deducted, okay? So opposite angles, so opposite, therefore angle R equals to 40 degree and angle Q equals to 140 degree. So this is how we got all the values of the angles. See, angle P as we got as 40, angle S as 140, isn't it? Angle R as 40 and angle Q as 140. Okay, I hope you kids understood. Okay, now moving on to the next one. So the next question here we have is two opposite angles of a parallelogram. Now again, two opposite angles of a parallelogram. See, if the figure is not given, you have to please draw the figure. It will be easier for you. Okay. So two opposite angles of a parallelogram are 6x minus 17 and x plus 63. Now they are talking about opposite angles of a parallelogram. So we know that opposite angles of a parallelogram are equal, isn't it? Find the measure of each angle of the parallelogram. That means we need to find all the angles of the parallelogram. So see what I have done here. Again, I have drawn a parallelogram. I have named it PQRS, familiar name, isn't it? I have marked all the sides as well with the relevant symbols, isn't it? Now opposite angles are given, so I have substituted the given term on the opposite angles as well. 6x minus 17, see, x plus 63 degree. Okay, now what we know is angle P will be equal to angle R. Opposite angles of parallelogram will be equal, as I have already told you. We know that as well, isn't it? So 6x plus 17 equals to x plus 63. These two will be equal. Now what do we have here? See, linear equation again. Concept of linear equation, isn't it? See, that is why I say every topic supports one another. Okay, so here now we have linear equation one variable, so x goes to other side, 17 goes to other side. We are sorting out the constant on the variable, isn't it? 6 minus x is 5x equals to 63 plus 17, it's 80, isn't it? So and finally we got the value of x as 80 divided by 5, that is 16. So see, this is how we can skip the steps as well, as I've been repeatedly telling you, okay, in order to save your time. So x equals to 16 degree. Now we need to figure all the angles, isn't it? X is not our angle because our angle was represented in terms of x, isn't it? 6x minus 17 and x plus 63. So therefore the angles are, say, as I have done here, angle P equals to 6x minus 17 Now we need to substitute x in here, the value of x. So we know the relation is multiplication. So 6 into 16 minus 17, that is 96 minus 17 is 79. Now I know that P and R is equal. They are equal angles, isn't it? Because opposite angles of parallelogram. So I know that R will also come 79. So just in case, if you want to cross-check your answer, you can substitute in terms of in the term where the angle R was given. Angle R was given x plus 63, isn't it? So just there I substituted x with 16, 16 plus 63. I got my result as 79. So I am double sure that my answer is correct, isn't it? Now simple, what I need to find angle S and angle Q. Now we know that these two angles are equal, but still we haven't got the value of the angle, isn't it? We need the exact values. What you can do is you can go with the angle sum property of a quadrilateral as well. Okay, but it will be a bit lengthy if you go with angle sum property, because you need to add all those 4 equal to 360 degree and all, isn't it? So instead, what you know is, you know that P and S, if you add these two, or if you add Q and R, you'll add these two, you'll get 180 degree angles on the same side of transversal, or co-interior angles, or interior angles, isn't it? Those were the reasons. Okay, so that's what I've done here. See, angle P plus angle S equals to 180 degree. See from the figure, angle P plus angle S equals to 180 degree, angles on the same side of transversal, the reasoning. Okay, now angle P, I got the value as 79, so 79 plus angle S equals to 180 degree. So 79 goes to other side, subtracts with 180 degree, you will get your result as 101. So angle S equals to 101. See, and what do I know? Angle S is equals to angle Q, isn't it? So since angle S is equals to angle Q, the reasoning, see, you cannot miss. Okay, for each and every thing you have written, new thing you write, you need to write the reason why. Okay, so opposite angles of a quadrilateral. So therefore angle Q is equals to 101. So now we got all the 4 angles. P, see, P, Q, P, where's Q? P, Q, R and S, all the 4 angles we got. Okay. Okay. So for question number 5, what we have here is, we are given with a figure in there, question number 5, and this is a mixed one. Okay, why it's mixed, you will get to know. Okay, why I just said it's a mixed figure, you'll get to know. Because see, what you have here is, you got a quadrilateral, you got the external angle, exterior angle of a quadrilateral, isn't it? And you got triangles as well. See, since a diagonal is drawn in a quadrilateral, so what actually a diagonal does in a quadrilateral is it divides into 2 triangles. For just one diagonal, remember, you can draw 2 diagonals, isn't it? But one diagonal divides a quadrilateral into 2 triangles. Okay, so we got quadrilateral as well as triangle, we got exterior angles as well. Okay, let's see what we are supposed to do. Okay, so in this one, find x, y and z. Okay, so we were given the figure was like this, so we need to find x, y and z. Now about x, if I take EFGH is parallelogram. Now what do I know? That opposite angles will be equal. Now x is opposite to this angle, but the value of this angle is not given, isn't it? But what I know is that GI, this line, GI is a straight line, and these 2 angles, there is a relation between these 2 angles, isn't it? These 2 angles are their linear pair, isn't it? If you add these 2 angles, you will get 180 degree. So that is what I have done here. See, but what say, since you are dealing with the external, exterior and interior angles and all, so I recommend, I have already told you, we need to write with 3 different points and a vertex in the middle. Okay, so that is what I have done here. FHI, see, angle FHI, that means this angle. FHI plus angle FHG, that means this angle. If you add these 2 angles, the sum will be equal to 180 degree. What is the reason? Linear pair. And since we had FHI as 70 degrees, so 70 degree plus FHG equals to 180 degree. This goes to other side, subtracts with 180, you will get 110. Now I got FHG, that is this angle, as 110 degree. So I got this angle as 110 degree. Now you can simply call, say, because it was given in the question that EFGH is a parallelogram, I can simply write angle X equals to FHG, isn't it? But why? As I have been telling you, the reasoning is very important. So opposite angles of a parallelogram. See, opposite angles of a parallelogram. Okay, So far we have got the value for x. Okay, now now again, and one more thing here, what I want you to tell you is the diagonal has divided the angles as well. But see, we have just been told about it's a parallelogram, nothing specific. That means we don't know that whether the diagonal has bisected the angle or not. Okay, so you cannot simply just like assume that they are equal and all. Okay, all we know is it's a parallelogram and there's a diagonal. Okay, so we need to figure out the values of y and z as well. And y is not a complete angle of f as well. See, similarly z is not a complete g angle for the quadrilateral, isn't it? They have been divided. So, and whether we don't know whether it's bisected or not. If it was bisected, then it would have, you would simply get z equals to 40 degree, isn't it? But since it's not said, so you cannot approach it that way. Okay, so how to approach for this one is, let's figure out. Okay, now what I have done here is, now in triangle EFG, see I have taken triangle EFG. Now in triangle EFG, so I have taken triangle EFG. So what you know in a triangle, okay, so what you know in a triangle EFG is that according to angle sum property of a triangle, yes. Now see, EFG, we are dealing with this triangle EFG. What do we know according to angle sum property of a triangle? That means when you add all the three angles of a triangle, we'll get 180 degrees, isn't it? So that is what I have done here. See, x plus 40 plus this angle, that is angle E plus angle F plus angle G. Since I have mentioned a triangle, that is why I can just simply write the angles directly, okay, using just one point. Okay, so angle E equals to 110 degree, angle E was angle X, isn't it? X was 110 degree, F, that's what we are supposed to get. G equals to 40 degree. So now added this to 150, goes to other side, subtracts 180, angle F equals to 30 degree. So here, what we have here is, we got this angle as 30 degree. Okay, so now see, why I have taken out this angle is because, see, and after that, what we have gone for is, now angle G is equals to angle F. We know that, isn't it? Angle G. That is, since, because EFGH was parallelogram, isn't it? So angle G was equals to angle F, and angle G was divided into two sections. Angle F was also divided into two sections. So opposite angles of a parallelogram. The reasoning is very important. So G was divided into 40 and Z, isn't it? So that is why in place of G I substituted 40 plus Z. See? Okay, can I do that? Did you understand this part? This EFGH is a parallelogram. EFGH is actually a parallelogram, isn't it? EFGH is actually a parallelogram. So what I just said is, if you take this as a parallelogram, opposite angles are equal. We know that angle G is actually a complete angle, isn't it? It's been divided into two small angles, 40 and Z. Similarly, angle F is divided into two angles, that is 30 and Y. So why I went for this one is because, see, I'll tell you, angle G we can substitute as 40 plus Z, angle Y we can substitute as 30 plus Y. Okay, let's keep it here. And here what we have is, we got linear equation. But linear equation we got in terms of two variables. Now remember one thing, a linear equation is two variable. We cannot solve a linear equation in two variable. Okay, we can only solve it in one variable. But what do I see here is, I have a relation between Z and Y. Now what is the relation? Can you figure out what is the relation? Now see, if you take FGH as a triangle, we have exterior angle of a triangle. Now what do we know about exterior? Exterior angle of a triangle will be equal to sum of its interior opposites. That is where we got the relation between Z and Y as well, isn't it? That means if you add Z and Y, you will get 70 degree. So that is what I have written here, out here. See, now in triangle FGH, according to exterior angle property of a triangle, Z plus Y equals to 70. Now for Z, what you can do here is, take Y to the other side, so it is 70 minus Y. Now you can substitute Z with 70 minus Y, isn't it? Now see, what we got the equation so far, we had here was 40 plus Z equals to 30 plus Y. So in place of Z, I can now substitute with 70 minus Y, isn't it? So that is what I have done here. See, 40 plus Z equals to 30 plus Y. In place of Z, I have substituted with 70 minus Y. I hope you get that, because Z was equal to 70 minus Y. See, I have just substituted. Okay, the place of z. Why so is because, see, from this point to this point, now we have linear equation in one variable. See, because you can easily solve linear equation in one variable, isn't it? So that is what we have done here so far. Okay, now so 70 plus 40 is 110 minus y, it will equal 30 plus y. You know the drill, isn't it? So I've taken y to the other side because plus y plus y. 70 plus 40, 110, 30 to the other side becomes minus. Y plus y is 2y, 11, 110, that is 110 minus 30, it's 80, so y equals to 40. Now we got the value of y as 40. So you got the value of y here as 40, isn't it? So what I've done here, I got the value of y, remember, I got the value of y as 40. Now again, what you can do is simply substitute the value of y out here in order to get the value of z, because we know z was equal to 70 minus y, isn't it? So that is what I've done here. See, 70 minus 40, that is equals to 30 degree. Now finally we got all the values of all the unknown angles, that is x we already had in the earlier steps, isn't it? And z and y, we got y, for y we got as 40, and for z we got as 30. Okay then, stay tuned in for more videos and updates. And what I want you to do is I want you to practice a few more sums from the topics. Okay, and please try to remember the properties. Okay, they are very important, because this one was very mixed figure, isn't it? Because we had to use the property of triangle as well, property of parallelogram as well. See, these kind of sums you will be facing on your higher levels. Okay, so the properties are very important. Please try to go through the properties, try to write it down and memorize it. Okay, so till then, stay updated. Okay, stay tuned in for more videos and stay safe. Take care. Bye bye.